Hello everyone and welcome to Machine Learning with Hamza. In today's video I'm going to present to you my machine learning toolkit. This toolkit contains the different tools that I'm currently using in my machine learning projects, as well as other tools that I find interesting that I want to share with you. So before we get started, I want to say that this tool encapsulates the necessary tools for any machine learning practitioner to tackle and to hopefully solve any machine learning problem that they're working on. I also want to say that this toolkit only contains the tools that are supported by Python, since Python is the most used and most popular language in the machine learning and deep learning field. So without further ado, let's get started. As you may know, when working on a machine learning project, the tools that we use always depends on the task that we have. So for example, we use different tools for computer vision, for natural language processing, and for simply exploratory data analysis. So I divided the tools in this toolkit in 4 categories. We have the exploratory data analysis category, we have the multi-purpose machine learning, we have the computer vision, and the natural language process category. So for each category, we're going to see an overview of each tool in it, and then we're going to see some simple examples on how to use each tool and what is basically used for. So let's start with the first one, which is exploratory data analysis. So basically, exploratory data analysis, or EDA, is the first step that we go through when working on a new data set, or after we collected our data and we're going to start working on it. So we have first to understand our data, to clean it, to prepare it, so then we can create our model and expect it to have good performance on the data we have. As you may know the saying, garbage in, garbage out. So basically we have to clean our data and to pre-process it very well so that we can expect better results. So for that, we're going to use 6 tools here. We're going to have Numpy, Pandas, Matplotlib, Seaborn, DataPrep, and Sweetviz. I selected these 6 tools based on the popularity of them and based on the personal experience that I acquired over the years. So the first 4 are Numpy, Pandas, Matplotlib, and Seaborn. These are very famous and very popular libraries that are basically used to create very thorough data analysis report. And for the last 2 that are DataPrep and Sweetviz, these are basically created to automate the exploratory data analysis step so that we can use them to automatically create reports on the structured dataset we have. So let's then start with the first one, which is Numpy. Numpy is basically a library that we use to create and manipulate multi-dimensional arrays, which are objects like matrices, if you're familiar with matrices in the linear algebra. So Numpy allows us to create these arrays and provides us with numerous functions and methods that we can use to manipulate them and to operate on them. So I think that Numpy is a very basic library and a very easy one to learn, and I think that it is mandatory for any machine learning practitioner to have in their toolkit, because mainly they're gonna need it and they're gonna use it in any project that they work on. So let's move on to the next library, which is Pandas. Pandas is the most famous Python library in the data analysis field. It allows us to import, clean, analyze, and visualize structured data. Basically, Pandas store the structured data sets we import in objects called data frame and series, and these objects are very easy to manipulate, and Pandas have a large collection of functions and methods that we can use to easily manipulate this data frame and series and to analyze the data we have. Using the first 2 libraries we discussed, which are Numpy and Pandas, we can create statistical analysis for our data, but we still need one more key to have a better report, which are visuals, and for that we're going to use Matplotlib and Seaborn. Both of these libraries allow us to create charts and graphics that convey the message visually, and to illustrate the statistics of the feature in our datasets. Both of these libraries are used for data visualization, but Matplotlib can be used for more than that. It can be used for any kind of general plotting. You can use it to plot any mathematical function or any statistical distribution, and we can say it's the most powerful plotting library in Python, whereas Seaborn is basically created for data visualization, and it can be used smoothly with data frame objects. For the last two libraries in this category, which are data prep and Sweetviz, these are created mainly for the automation of the analysis process, and using them we can generate an EDA report in basically 1 or 2 lines of codes. I personally use them to have a quick look on the data I work on and to have a better idea on which features to focus on and which strategy I need to follow when conducting the analysis. So to summarize, when performing EDA, we can start with the data prep and Sweetviz libraries to have a quick overview over the data. Then we can use Numpy and Pandas to manually investigate and clean our data. Finally, we can use Matplotlib and Seaborn to produce graphics for our final report. So that's it for the overview. Now let's move on to see some example for each library. So the first library we're going to start with is Numpy. As you can see in the first example here, we can use Numpy to generate an array of random integers. We can check the type of the object created which is in the array. Then we can use some of the Numpy methods to see the attributes of the created array. For example, here we can see the shape of the array, the number of array dimensions, and the type of coefficients. Using the shape, ndim, and dtype methods. We can also see some example of the mathematical function that we can use here. Here we have the sum function, the mean function, and the median function, which can be used to calculate the sum, the average, and the median of the Numpy array. Let's move on to the Pandas example. Here we have imported the cars dataset, which is stored in a CSV file. We can use the head method to display the first 5 rows of the dataset, and we can see here that we have 7 numerical features in our dataset and 2 categorical features. Let's see now how we can use Pandas to conduct a brief EDA. So we can start by using the describe method here to check for sample statistics for each numerical feature. Then we can check for duplicated rows or for missing value in each feature using the duplicated and isNA method. Then using the value counts method, we calculated the number of car categories, and using the group by method, we calculated the average of each numerical feature for each car category we have. That's it for the Pandas example. Now let's move on to the next 2 categories, which are used for data visualization, and let's see how we can use them to create some plots and charts. The first one is Matplotlib. In the next example, we can see that we can use Matplotlib with the Pandas data frame to create some visuals for our cars dataset. So here we created a bar plot for the number of cars per country. We created a histogram plot for the distribution of horsepower. And we created a scatter plot which convey the correlation between the miles per gallon and the acceleration features. Moving on to the next example using Seaborn, we created more visuals here for our cars dataset. And as we can see here, we have better visuals and better graphics for each plot. In the first figure, we created a scatter plot of the weight versus the horsepower features, and we color-coded it using the cylinders feature. We also color-coded the histogram of acceleration in the second figure, and in the final figure we created a correlation map of the numerical features present in our dataset. So now let's move on to the final 2 libraries in the first category, which are data prep and Sweetviz. So these libraries, as we discussed earlier, are used for EDA automation. Using the Sweetviz library and in only 2 lines of code, we created an EDA report. As we can see here in the EDA report, we have an overview of the features in the dataset. We have basic statistics for each feature, and the distribution is illustrated for all the numerical feature present in the dataset. And we can check for more details of each feature by selecting it in the tab we have. Here we can see for the MPG feature, which is numerical, it gives us the most frequent value, the smallest values, the largest values. It also gives us the numerical association with other features, which is basically a Pearson coefficient, which convey the correlation with other feature present in the dataset. We can also use the Sweetviz library to compare 2 datasets. For example, if we have a validation set and a test set, and we want to check if both sets have similar distribution so that the model performs better. So here, using Sweetviz, we can do that. For now, we don't have a second dataset, but it is easily used in 2 lines of code. So now let's move on to the data prep library example. Here we generated a report using the create report method, and as we can see, we have a similar report as the Sweetviz, whereas in this report we have more details and more tabs that we can check. For example, here we have the missing value tabs, which allow us to see how many missing values are present in our dataset. We have the correlation tab and the interaction tab for the correlation between features, and we also have a tab for each feature present in our dataset, where we can click the show details and show more details and more statistics about each feature in our dataset. This tool is very powerful and can be used to quickly understand what's going on with the dataset we have, and to have an idea about how to clean it and whether to focus on certain features and whether to engineer more feature in the dataset or not. So basically that's what I use it for, and hopefully you find it interesting and you use it in your machine learning projects. Okay, so that's it with the first category. So now let's move on to the next category, which is the multi-purpose machine learning and deep learning tools. And in this category, we're going to see the tools that can be used for a wide range of tasks, ranging from supervised to unsupervised learning, for classification tasks or regression or clustering, etc. In this category, we also have 6 libraries. We have Scikit-Learn, Tensorflow and Keras, PyTorch, FastAI, JAX and Flask, and finally Picard. So let's now see an overview of each library we have here, and then we're gonna move on to the examples as we did for the first category. So the first tool in this category is Scikit-Learn. It's a very famous and robust Python library for machine learning. It provides us with a wide range of algorithms for both supervised and unsupervised learning. It also has many methods and functions that we can use for model selection and evaluation, for data pre-processing and post-processing, and also it provides us with a pipeline utility which helps us to automate our machine learning workflow. I personally think that Scikit-Learn is the first library that we need to learn if we're gonna practice machine learning using Python, since it is a very beginner-friendly library and it has a wide range of implemented algorithms that I think any machine learning practitioner should learn and should know how to implement. So that's it for the first library, Scikit-Learn. Now let's move on to the second one, which is TensorFlow, and it's a higher level API Keras. So TensorFlow is the most popular library for deep learning in Python. It can be used to create new models architectures, but this requires deeper knowledge of its lower level API. but it also can be used via its higher level API Keras to quickly build flexible deep learning models. TensorFlow can be used across a range of tasks in multiple fields like NLP, computer vision, audio processing, and even reinforcement learning using the TF agents. The next library in this category is PyTorch. It's also a very famous library for deep learning in Python, and it has attracted more researchers over the last couple of years, which made it very famous in the research community, and many more papers were produced using PyTorch. From my personal experience, I started learning deep learning 3 years ago, and I started with TensorFlow 2.0, and that made it easier for me to understand how the model's architectures are built and how each component is working and how to do hyperparameters, research, etc. And I still think that even today, if you want to learn deep learning, starting with TensorFlow and Keras is a good choice for you, because as I said, TensorFlow 2.0 has the higher level API Keras, which is easier to learn and to better understand the concepts, and the transition from TensorFlow to PyTorch, if you're willing to continue with research or to continue as a machine learning practitioner, you can easily transition from TensorFlow to PyTorch, and you can easily learn how to work with the PyTorch framework and to incorporate the new architectures and developed models using PyTorch in your machine learning projects. I also believe that both TensorFlow and PyTorch are very powerful frameworks, and both can be used to produce production level models for most standard tasks, but only for some of the state-of-the-art models, such as the pre-trained BERT from the Transformers library. These models are only supported by PyTorch for now. Maybe in the future we have similar models or better ones that are developed on TensorFlow. But for now, some of the state-of-the-art in both natural language processing or computer vision are only developed and supported by PyTorch. So this is something that we need to also keep in mind. But I also think that learning both library is not very hard to do, and transitioning from one framework to the other is a fairly simple task, because the main concepts of deep learning are shared in both frameworks, and the main idea behind the development, the tuning of the model is also shared in both frameworks. Next on the list we have Picard. It's a fairly new low-code machine learning library released in 2022. It is written in Python, and it is developed to help automate machine learning workflows for structured data. I basically use Picard to train and compare multiple machine learning models. Then, depending on the results, I choose the best performing model and I retrain it and tune it using other libraries, which allow for better flexibility and better tuning of the models. That is because Picard is a black box library, which doesn't allow for much model customization and tuning. Then we have FastAI, which is a Python library for deep learning developed on top of PyTorch. And as described on their official website, it is a deep learning library which provides higher level component that can be used to produce state-of-the-art results in few lines of codes, but it also provides low-level components which can be mixed and matched to produce new models and to build new approaches. It also provides a large collection of pre-trained models for computer vision and natural language processing, and with a handful lines of code, we can produce great results. I recently started using FastAI when I started learning natural language processing, and indeed it is a very powerful library and it has a lot to offer, especially in the natural language processing field. The last framework in this category is Flask. It is a new library in the deep learning field. It has been released in 2022. It is a neural network library for JAX, which is built for flexibility. And JAX is basically, if you don't know, a Numpy compiler which runs on the GPU. so it has potential for high-speed computation. And Flask is the deep learning library built on top of JAX. JAX also allow for fast scientific computation through parallelization over multiple GPUs and TPUs, and this obviously will give a huge boost for deep learning models training using Flask. I also want to mention that there is another library for deep learning built on top of JAX by DeepMind, which is DM-HiQ, but I was more interested by Flask because simply Flask comes with optimizers, mixed precision, and some training loops, whereas DM-HiQ was only developed as a solver for neural networks, and it leaves other parts for other libraries such as Optax for optimization. And I want to say that I still have not started using Flask yet in my projects. However, it is definitely on the top of my list of deep learning frameworks that I find interesting and that I believe that have great potential. So now let's move on and see some simple examples on how to use these libraries. So the first one is Scikit-Learn. Here we're gonna use the cars dataset that we seen earlier. So here we use the train and test split from Scikit-Learn to split our data for training and testing. And then we created standard scaler to normalize our features. And then we created an MLP regressor model to predict the miles per gallons. And here we can see the score of the trained model on the test set using the mean squared error. Now we're gonna move on to the next libraries, and we're gonna train similar models and compare maybe the results using the PyTorch. Next, we created a simple MLP, which is a multi-layer perceptron, and we created the training loop. We trained our model, and then we can see here the mean squared error of the trained model. Next, using TensorFlow and Keras, we trained similar MLP model, and we trained it over 1000 epochs also. And here is the score, or the mean squared error over the test set. Next, using FastAI, we created a tabular learner. We trained it for 100 epochs, and then we can see the score here, the mean squared error, which is the best up to this point. Finally, we're gonna use Picard to train multiple machine learning models and compare their results. Yeah, and as we can see here, we can do it in only one line of code. We first need to create the session. Then we use the compare models to train 18 different models. And as we can see here, the ridge regression model gave the best result with the least mean squared error. We can then also evaluate the trained models using the evaluate model function. And as we can see here, we have multiple tabs for hyperparameters, for residuals, for prediction error, Cook's distance, etc., which allow us to better select our model and to see which one performed better, and give us an idea on how to tune it further using other libraries. So that's it, guys, for this category. Now let's move on to the next one, which is computer vision. So the libraries in this category are mainly used for image manipulation and pre-processing, and as we said earlier, using the tools of the previous category, we can develop models for any kind of deep learning tasks or machine learning tasks, including computer vision. So here we're gonna see how to use these libraries to manipulate and to pre-process image data. The first two libraries we have, which are Opencv and Scikit-Image. Both of these libraries provide a collection of algorithms to manipulate and to pre-process images. I prefer using Scikit-Image for simple tasks like filter application or image resize or image manipulation, but for more advanced tasks like feature extraction and face detection and more complicated tasks like that, I prefer using Opencv, which is more sophisticated and it has a bigger community on the internet, so you can find any answer to your question very easy and very quickly. Next on the list we have Pillow library. Pillow is simply a library that adds support to Python to manipulate, open and save images in many different formats. Finally, we have Tesseract, which is a Python library for optical character recognition. It is basically a wrapper for the Tesseract OCR engine of Google, and it supports a wide range of languages. So now let's move on and see some examples on how to use each library in this category. The first one, which is Opencv. We here used Opencv to open and read an image. Then we created a cascade classifier, which is going to detect the faces in the image that we imported. And as we can see here, each detected face is put in a green square. And as we can see here, it detected 10 faces in this image, which is quite powerful, and it only required few lines of code to achieve this result. Next, we're gonna see the same example, but this time using the Scikit image library. So we imported the same image, and using the detect multiscale function, we're gonna detect the faces in this image. And as we can see here, it detected almost the same faces as Opencv, with only a few mismatches. So that's it for the face detection. Now we're gonna see how to use the Tesseract alongside with the Pillow to perform OCR. We used the Pillow library to import the image, and within one line of code and using the image to string, we extracted the text out of the imported image. Okay, so now let's move on to the last category we have, which is natural language processing. And in this category, we only have 4 libraries, which are Gensim, Spacey, NLTK, and Transformers. So I want to say first that my interest in the NLP field has been growing very much since the introduction of Transformers mechanism in this field. And these new research results allowed for great models like GPT-3, XLNet and BERT models to have great performance on multiple NLP tasks such as question answering and text generation, etc. So that's what captured my attention, and I was interested in this field. And as I started learning NLP a few months ago, I came across these tools, which I find very interesting and has a lot to offer. So let's go through them one by one. The first one, which is NLTK for Python, or the Python Natural Language Toolkit. So this toolkit is very popular NLP library in Python. It provides many tools for symbolic and statistical natural language processing in Python for the English language. So we can use it, for example, for text tokenization or bag of word creation and many more other applications. So now let's move on to the next library, which is Spacey. It is a more advanced library than NLTK and can be used for advanced application in natural language processing, and it provides many more powerful algorithms for tasks like sentiment analysis and named entity recognition and many more other algorithms. Next on the list we have Transformers from Hugging Face. It is by far the most powerful library in deep learning for NLP. It has a big community and it is very well documented. Finally we have Gensim, which is a Python library for NLP. It provides a special feature to identify semantic similarities between two documents by the use of its space vector modeling and its topic modeling toolkit. But the most advanced feature of Gensim is its processing speed and its great capability of memory usage optimization. Okay, now so let's move on and see some examples using these libraries. The first example we have is using NLTK. So in the first example using NLTK, we performed named entity recognition, and as we can see here, it successfully identified Elon as a person and Musk as a person, and it wrongly identified Google also as a person. So let's see how we can perform the same task using Spacey. And as we can see here, it correctly identified Google as an organization, but falsely identified Elon Musk as an organization also. So finally, we're gonna see the same example, but here using the transformers library and using the NER or named entity recognition pipeline. We can see here that it correctly identified Elon Musk as a person with a high confidence score, and also Google and Tesla as an organization with a very high confidence score. So that's it guys for my machine learning toolkit. I hope that you find it interesting, and if so, don't forget to subscribe to stay tuned for the next videos. And until the next video, stay safe.